Okay, good morning, everyone. I hope you are doing good. We're back to our lesson again. I hope you had a nice week since we left last Thursday. As we agreed last, we said that we can only allow wenye wameinua mkono kuongea. So if you want to talk, you raise up your hand. I'll see your hand, and then I will unmute you to talk. Do not attempt to unmute yourself kama haujakubaliwa kuongea. Then, of course, I expect that we take a lot of time in discussion. Let's engage with everyone. Then we'll be okay. Now, lastly, I hope everyone is okay. So at least you can sample whether people are okay. Let me just start by at least greeting a few of you. This is Adrian Kipkorin. Adrian. 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 Since Adrian has a problem, this is a Adrian. Alex Curtis.
Yes, teacher.
Good morning.
Good morning, Mr. Mwenda.
All right, so at least you can hear me now. I want us now to directly move on to our thing today. Alex, were you in my class last time? I want to see those who were in class last time, because I know some of you were last time, others were in. So I think this is Alex Boy. Alex Boy. Alex.
Yes.
Good morning.
Yeah, morning, teacher.
You were in class last time?
Yes, I was.
Now, what did you do last time? The last Thursday?
We introduced ourselves to the topic pressure, and we handled pressure in solids.
In solids, and we're able to read more on tulisoma kuhusu maximum pressure and minimum pressure. That is what we learned last time. All right. Now, from that concept, then let me get to know, this is Barak. 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 Seems Barak, you're not together. Then
yes.
I think Alan Kiprop. This is Barak.
Yes.
Now, we learned about maximum pressure and minimum pressure.
Yes.
Which other one did we give to minimum pressure? We said minimum pressure can also be called Barak. Barak. Right, Barak seems not to be. Boy, Alex.
Pardon?
Alex Boy. We learned about maximum and minimum pressure. Which other name did we give to maximum pressure and minimum pressure? Just as a reminder of what we did last day. Uko low, Boy, uko chini kabisa, see what is not happening? Kama uko na earphones toa earphones.
Yeah, maximum pressure can also be called the largest pressure.
Maximum,
And minimum can be called the least or smallest.
All right, that is what we said last time, and we were able to do that, and we did very many examples, and we also discussed about practical application of maximum and minimum pressure in daily life situation. That is what we learned last Thursday. Now, we had very many examples that we did, and I believe that everyone was able to understand. We explained our examples, we explained what we were doing, until we also went to practical examples in daily life situation. So today, we had agreed, that is, Boy. Boy.
Pardon me.
We said, what will you be doing today?
We'll be doing pressure in liquids.
Pressure in liquids. All right. So that is what we should be moving on to. And let's go on now to pressure in liquids. I will just do a projection hapa kwa board, then we move on. This is just a minute. I want to do a projection of something, pressure in liquid. And I said, if in case you have a question, kindly raise up your hand. I'll see your hand and then I'll address your question. So if you have a question, don't just keep quiet with that. Raise up your hand, nitaiona. Then kama hauna swali usiinue mkono, because we have some of us who are raising up their hand when they don't have question, and then they tell me, mwalimu, mkono imejinua na umeclick. Ask a question, raise up your hand. If you have a question, then ensure you raise up your hand so they can see it. Then let's move on to this. Let me have a projection up. Just a minute. That is pressure in liquids. Pressure in liquids, and that is where we are starting today. Pressure in liquids. Now, when we talk about liquids, of course, it's a basic one that a liquid is one of the three states of matter. We have the solid, we have the liquid, and we have the gases. Now, how do you want to know, before we start now discussing pressure in liquids, what is the difference? If someone asks you, what is the difference between a liquid from other two states of matter, how do you explain that difference? Ama utaelezea mtu aje tofauti ya liquid na the other states of matter, that is gas and solid. Why is the difference between liquid and the other two? And I want to get from someone, this is Stephen Kaberia. Stephen Kaberia?
Liquids have indefinite shape, definite volume, and definite mass. Solids have definite shape, definite volume, and definite mass, while gases have indefinite volume, indefinite shape, but definite mass.
That is basically, at our level, we understand liquid as having definite volume and definite mass, but does not have definite shape. The volume is definite, the mass is definite, but shape is not definite. That means liquids take the shape of the container. Basically, we had discussed and said, Kaberia, Stephen Kaberia, I still want to just make a review of pressure in solids so that we can use that as our point of reference to discuss now some of the formulas we shall drive in pressure in liquids. But before then, we need to remind ourselves of something. Stephen Kaberia. Dogo Kaberia, let me just unmute you. Stephen Kaberia.
Yes.
We saying that in solids, how do we find pressure?
Force over area.
Force over area. Now, but we've said that when we come to liquids do not have definite shape. Therefore, it is hard for us to get the area. If they don't have shape, then if the area, we will not be able to understand or tell which is the area of a liquid. Therefore, when we come to liquids, in solids, we say that solid has got definite shape and definite volume. But liquids do not have definite shape. Therefore, even getting the exact area, that is why we should expect a different formula of finding pressure in liquids. And I want to start by, first of all, we understand factors affecting pressure in liquids. We start with the first factor. Nataka mtu mmoja tusomee these factors. This is 4. Alan, Alan.
Yes.
Yes. So those factors that are projected on the board.
Factors affecting pressure in liquids. Depth of the liquid. Pressure in liquid increases with depth. This is the reason as to why walls of a dam are thicker at the bottom than at the top. At the bottom of the dam would stand high pressure due to water at the liquid. At the bottom of the sea experiences more pressure due to more weight of water above him than a diver near the top or stroke surface of the sea.
Now, just hold on, Alan. Now, I want us to note factors affecting pressure in liquids, and you've said that the first factor is depth of the liquid.
Yes.
And the explanation we are giving is that pressure in liquid increases with depth.
Yes.
I want us to, and then we have given an example. It explains why. It explains why the dams are shaped in that manner. We have the diagram hapo kwa board. If you look at that diagram, at the top of the dam, the walls are thin. At the bottom, the walls are thick. Why are the walls thick at the bottom of the dam, Alan?
So that the thickness at the bottom of the dam can withstand the pressure due to the volume of the water as pressure in liquid increases with depth. So the pressure at the bottom of the dam will be more. So the bottom of the dam should be larger than the top because there is more pressure there.
At the bottom, where the depth is very high, the pressure is very high. That is why you are saying pressure in liquids increases with depth. So up you at the top of the dam, it is thin because the pressure is low. While at the bottom, where the pressure is very high, the thickness of the wall is, or the walls are very thick because the pressure is very high. Now, I would want someone to tell me what would happen if the walls of a dam are designed with the same thickness. Kutoka juu mpaka chini, they are designed with the same thickness. What would happen to the dams? Or what would be the effect of that dam? Someone tell us. Let me get from Manuel. This is Manuel Southwest. What would happen? Manuel?
Yes?
What would happen? What would happen?
The walls at the bottom would break, disintegrate.
Break. Now, just a practical example. That is okay. But just a practical example. I do not know how many of you heard of the Solai Dam in Nakuru. I think some few years back. Manuel, may I hear your story?
Yes.
The Solai Dam. What happened to the Solai Dam?
It burst the banks.
It burst. It burst from the ground part of it because it was claimed that there was poor workmanship, that the dam was poorly designed. To me, I would think probably there was some poor workmanship, that the bottom of the dam was poorly designed. The walls are not that much thick. Therefore, when the pressure built so high at the bottom, the dams ended up bursting the walls because of high pressure at the bottom. So,
yes.
Then we move on now. We move on to another explanation. Someone at the bottom of the sea, ule mtu ako kwa tuseme hata ni kwa sea ama kwa swimming pool, those who are good swimmers will testify this, that where do you experience very high pressure? Is it at the deep end or at the shallow end? Yes, Manuel?
At the deep end.
At the deep end. Why do we experience high pressure at the deep end of the swimming pool?
Because there is more pressure due to the weight of the high weight of the water above you than a diver who is at the shallow end.
Which is caused by the depth of the water at the deep end. So,
yes.
Those are now practical examples of application of pressure in liquid increases with increase in depth. Now, I will just give something up on the board, then someone try to explain. It's a very common one. I know Mulifanya primary. There is a very common diagram that is given. You are doing it in primary. Kuna diagram ilikuwa inakaa hivi kwa primary. This is something like this. This is water. There is kuna hole A, B, and C. This is A, B, and C. Then you are asked which hole will have the longest sprinkle of the water. Which one? Can I get from one of you? Let me get from Stephen Moredi. Stephen Moredi?
Yes, the hole that will throw the farthest is hole A.
Why hole A?
Because pressure increases with depth.
With depth. And hole A is on the longest depth. Ama ndiko na depth kubwa. Sawa sawa?
Yes.
Yes.
All right. So we now move on to something else. Another factor that affects pressure in liquids. Another factor. We now move on to the next factor. Just a minute. Just a minute. We move on to the next factor. Yes, we now someone to read for us this. This is Bryson. It's Bryson Yaga. Where are you? James John. James John. James, can you? James. James, you're not with us. Let me get from Idris Juma. Idris Juma?
Yes, teacher.
Yes, read for us the next factor that affect pressure in liquids. Yes. Iko hapo kwa board, read for us and then we try not to explain from there.
Pressure in liquids increases the density.
With?
Density.
That is the next factor. The next factor that determines the pressure in liquids is the density. And then go on and read for us what is on the board.
Pressure in liquids increases with the density of the liquid. Consider two identical cylinders filled with water of density 1000 kilograms per meter cubic and glycerin of density 1260 kilograms per meter cubic respectively. Pressure at point B is greater than pressure at point A because glycerin is denser than water and therefore exerts more pressure than water.
Now, I want us to look at those two liquids. Let's look at those two liquids. We have the glycerin and we have water. Which one has the highest density? Idris.
Glycerin.
Glycerin has got 1260 kg per meters cubed, while water has got 1000 kg per meters cubed. If you look at the diagram, let me just try to enlarge for the sake of those who may not be clear. Looking at those diagrams, on water, we have the hole at A and at B. So if you compare at the bottom of the glycerin and the bottom of the water, at B, the pressure is very high. The pressure is, because if you look at that point, the depth is the same. The depth is the same. So in that case, depth is not a factor because the two parts, A and B, are at the same depth. But what is causing high pressure at B is because glycerin has got high density than water. Therefore, we say that pressure at B is high because of the varying of density. What about if, let me just compare, let me just have this question. To assume tulikuwa na something like another liquid hapa. Let me call it, which is identical and the height is the same. Kitu kama milk. Let me call it milk. Milk iko na pressure ya 1.2 grams per centimeters cubed. Then you are told this is C. Arrange them the above containers in terms of their ascending increase in density. They are ascending pressure. Sorry, they are ascending pressure, not density. So can we arrange them? Let's know which one has got the highest pressure, which one has got the lowest pressure. Can you arrange them? Someone to arrange. There is A, B, C. Someone to arrange for us and tell us how do they arrange themselves? A, B, and C. Zinajipanga aje in terms of their ascending pressure. Someone, this is Bryson Yaga.
Yes.
Arrange those containers in their descending order in terms of pressure.
Glycerin will have the highest pressure because it's the denser one, then followed by milk, which is 1,200 kg, then followed by water, which will have the least pressure.
So arrange them in their ascending order.
Glycerin, milk, and water.
Wait. Ascending order. What does ascending order means?
Water, milk, and glycerin.
All right. So that is the order we should be arranging with. That's a very common question in Form 1 about the increase of density depending on, increase in pressure depending on density of a liquid. So note that. Because some of us are likely to have, umechorwa those two containers. Umechorwa ukambua which part has got the highest pressure and why. Then you realize that some of us are now wanna struggle kuelewa what am I considering in this case. Note, if we have two containers which have got two different liquids, then you must know what they are testing. In this case, it is pressure increases with density. Now, let me just have this, because hii tumepewa, we are given the density of the liquid. What about, let me just have something happen. What about if we are using water and mercury? Because this is water, this is mercury. This is water, this is mercury. Then this is A, this is B. Now, which among those parts, part A and part B, will have the highest pressure? Yes.
Part B.
We have A and B. Which one has got the highest pressure and why? Newton Mudaura. Newton.
Mercury will have pressure.
Newton. Pardon? Newton, you're not clear? Pardon. Newton, umepotea sijui nini mbaya? You are punishing kama umevaa headphones, toa headphones. Itakusumbua sana. Kama umevaa headphones sauti yako isikiki. Without I don't know what is. Let's get from Kariuki Steven. Kariuki Steven.
Kariuki Kelvin.
I don't know who is that talking behind the doors. Let me get from Manuel.
Yes.
And now, which one between the one with mercury and the one with water that will have high pressure and why?
Mercury, because of a higher density than water.
What is the density of mercury?
13,600 kilograms per meters cubed.
Good. Those are the things now you should be expecting in an exam. Unaona kuna zile, there are those liquids that their densities are known. They won't tell you this is density. For example, what we have on the board, nimewambia densities of those liquid. Glycerin nikakwambia ya water. In an exam situation, it might be umepewa two liquids, and they will give you two liquids that their densities are known. So it's upon you now to understand that hautaambua density ya mercury ni E, outer bound density ya water ni E because their densities are known off head. Ziko two established and they are known. So if you find that you are told these are two identical containers which have got a liquid and the depth is the same, then you must be able to tell that they are testing that pressure in liquid increases with increase in depth. Note that. Then let's move on to something else that is about factors affecting pressure in liquids. We now move on to how do we get pressure in liquids. That is the next thing. How do we get pressure in liquid? Just a minute. Pressure in liquids, we have something we call to as the fluid pressure formula. Like we had said in solids, we say that pressure is given by force over area. Or in other words, we said weight over solid over its area. But I said because liquids do not have definite shape, we cannot use the formula for weight over area. So let's move on because we might be having different shape of the container. So it's very hard for us now to get the area of the container since the shape is not definite. So what we do, we try now to drive the formula for finding the pressure in liquid, and we call it the fluid pressure formula. And I'd like to come step by step so that let's have someone to read for us that step by step so that we can know how that formula is arrived at. And I'll start by this is Godwin Kibet.
Yes.
Kibet? Now read
Yes.
for us that statement ya juu hapo step by step.
Statement 1. Consider a container with cross-section area A filled with liquid density of P to the height H as shown below.
Simama hapo. What are we given? We are given the first thing, the first variable we are given is cross-section area. Tukapewa ni Kibet? Umeambiwa ni A. So the area is given as A, capital A. Na kila mtu sahi, I think everyone has got a book somewhere with a pen, and we're trying now to follow step by step so that we can know how we arrive at that. So Kibet.
Yes.
You have uko na kalamu yako, eh?
Yeah.
And your book close to you.
Yes.
So I want to move step by step now, so that we get to the formula that we have upon the fluid pressure. So we have area as A. What else do we have? Filled with liquid of density.
Yes.
Density, sindio?
Yes.
Hiyo ni nini nasomango aje? Density?
The formula.
So hebu soma hiyo statement, filled with liquid of density.
Statement 2.
Inasoma?
Statement 2.
No. I want hiyo sign wameweka hapo after density. How is it read?
Rho.
Good. So density is rho tuko nayo. Then what else do we have?
The height.
The height is H. So those are the variables that we have, and we should now be using them to find the pressure of the liquid. We are given a container. Which shape is that container?
It's cylindrical.
Cylinder. Sawa.
Yes.
If we want to get the pressure of that liquid, we know from the first introduction pressure in solids, how do we get pressure?
Force over area. Pressure is equal to force over area.
Force over area. And we called force the same as what? Weight.
Weight, yes.
So we want now to find the pressure exerted at the bottom of that container by that liquid. So we say that the pressure of that liquid will be given by the weight over the area. Sindio?
Yes.
From for the topic of force, how do we get weight?
Weight is equals to mass times gravity.
That is mg. Sawa.
G. Yes.
And then the next thing is that we've seen that weight is equal to mg.
Yes.
And then what is mass? From the
Mass.
formula of density, because we have density upper.
Mass is equals to density times volume.
Mass is equal to density
times volume.
Times volume. So,
yes.
Now, from that container that we are given is a cylindrical container.
Yes.
Then how do we get the volume of that container?
The volume of the container is equals to
how do you get the volume of a cylinder?
Mass density. Volume is equals to pi 22/7 pi r square h.
Now, from what we are given, avoid using pi.
Area times height, cross-sectional area times height.
Sorry?
The cross-sectional area times height.
Cross-sectional area to now, which is A
times height.
Height, sindio?
Yes.
So therefore, we can say that mass is equal to rho, that is density, times A times H, sindio?
Yes.
And then let's go back to now. We have mass as density, that is rho, times A times H. We can say weight is equal to mg, sindio?
Yes.
And we convert m ikakuwa nini? Ikakuwa rho times A times H, sindio?
H. Yes.
Right? So
yes.
Let's now move on and say what will be weight. Itakuwa ni?
The weight will be mass times gravity. Mass times gravity.
Mass times gravity. And we have gotten our mass as what?
As rho times A times H.
Then what is our weight in terms of all those factors, those variables? Itakuwa rho
A H
times A
times
H times G.
Over.
Sindio?
Yes.
Times G, because now we are saying that weight is equal to mg. So now weight is equal to rho times A times H times G. Sindio?
Yes.
So let's go back now to what we had initially. Tukasema pressure is equal to weight over area, right?
Yes.
So can we now say that is weight? Now with here tumesema ni density, that is rho times A times H times G, then all that divided by A. So.
Yes.
Then what happens? We have common. Can we cancel anything?
Yes. A.
Can we cancel?
A.
So what are we left with? Pressure is equal to
H times rho times G.
H times rho times G. And that is what we call to as what? The fluid
formula. Pressure formula.
That is pressure in liquids is equal to H rho G.
And
gravity.
Yes.
And what does H represent?
H, the height.
The height of what?
The cylinder.
Not the height of the cylinder, but the height of
the liquid in the cylinder.
So it's not. Let's forget now about the cylinder. We have just used cylinder as an example. So
yes.
We now note that it is the pressure, the height, or H is the height of the liquid, and rho is the density of the liquid, and of course G is the gravity, which is always constant. So
yes.
So the formula P is equal to H rho G is called the fluid pressure formula. So some of you might be asking, where do we get this formula from? Because I know some of you who come to my inbox for questions, you just come with the formula, but we want to prove how we got to the formula, then it's a problem to many. But at least now we're able to derive the formula and know how it is arrived at. And I want to let you know that that one is an examinable question. It's a very examinable question. You are told that given that a container has a cross-section area A, filled with a liquid of density rho to the height h, show that the pressure of the liquid is given by h rho g. 4 marks or 3 marks. In other words, you are supposed to derive that formula. So, anyone with a question at that level? Na mtu akona swali? Na mtu akona swali? Naona watu wameinua mikono. Kuna watu wako na swali. Any question? Firstly, Akim. Firstly.
Yes. Sure.
Firstly.
Yes.
Swali.
I wanted to ask if you could enlarge the image. Yeah.
Oh, the image.
Yes.
All right, no problem. I can do that. Any other question from? I'll do that, of course. Stephen Moredi, swali.
I was asking if during an exam, you are asked to derive the formula. Do you write sentences or do you just do the working?
Sorry?
Do you write in statements or you just do the working?
Of course, there are points you have to give the statement. There are areas you just have to, you must give statements somewhere. For example, in that when you are driving, let me just go back to what we have on the board. Just a minute. When we are driving that equation or that formula, that P is equal to H rho G. Of course, from the starting point, I've said you a sample question is you are given unaambiwa kama hivyo hapo tumesema hapo juu consider. In an exam situation, you'll be told, given that a container has a cross-section area A filled with liquid of density rho to a height h, show that the pressure of the liquid will be given by h rho g. That is a very common, that is the kind of question you expect if you don't drive. Tuko na diagram na tuko na hizo variables tumepewa A, rho na h. Of course, you cannot just start with just working peke yake. You must say pressure is equal to force over area. Then go on and say it's bracket weight over area. And when you are, let me just do something on the board. And when you are doing that, you must say weight into bracket W over area into bracket A. Hiyo A umepewa hapo. Ensure you have those variables and their abbreviations. Then you move on now, but we know at hiyo swali we have nothing like mass. We have nothing like gravity. So you have to come and tell us using a statement, but we know that weight is equal to mass times gravity. So that now you introduce now W is equal to mg. And you move pole to the last step where you cancel A, and you are left with H rho G. I think you can, those who are using phone, you can have a screenshot of what I've given Hapo. You can take a screenshot of that working. That is how you drive that formula. Any other question from someone?
Thank you, sir.
All right. Okay. Mwingine akona swali? Ben.
Yes, teacher.
Swali?
Chair, at that point where you have written that, but W is equals to mass, gravity is equals to rho, and then from there I did not understand how we go on.
Ukitoka hapo juu tunasema pressure is force over area, right?
Yes.
Which is equal to weight of the liquid over the cross-section area of the container, which is the same cross-section area of the liquid, sindio?
Yes.
Then hapo chini tunasema, but we know W, which is weight, is equal to mg. Sindio?
Yes.
Na nikasema hapo, note that mass is equal to density times volume.
Yes.
Are you there?
Yes.
Where volume where volume is given by cross-section area times H, which is AH. Unaona hapo? Then we now go back and say that, therefore, weight is equal to mass times gravity. That is where we stopped. Sindio?
Yes.
After getting that weight is equal to mass over gravity, and we now go on and get that mass is equal to density times volume. Uko na kalamu kwenye huko? So can you write somewhere that mass is equal to density and give it rho times volume?
Mass?
And mass is equal to density times volume. Sawa sawa?
Yes.
Umeandika hiyo?
But
volume is equal to A times H, which is cross-section area times height. Sindio?
Yes.
So therefore, mass is equal to density times A times H.
Yes.
Sawa?
Yeah.
Then we go back to our initial statement that weight is equal to mg. Go up, If m is equal to rho times A times H, can you replace and get weight, which will be given by, sasa toa hiyo m hapo, replace with the values that you have gotten hapa chini. Unapata weight is equal to?
Wait.
Replace m sasa, because tulikuwa tumesema weight is equal to mg. Sasa replace m na hizo variables za rho, A and H. So
weight,
you get weight as?
Weight as rho times area times H.
Times G, sindio?
Yeah.
Because we are saying that weight is equal to mg. So finally, we go back to the formula of pressure. Because tumesema pressure is equal to weight over area.
Yes.
What's up?
Sijui
kama kuna mtoto hapo background.
All
right. Then we have said weight is equal to rho times A times H times G, then over area, which is given by A again. Sindio?
Yeah.
Then cancel the area A and A. Hiyo A ya juu na A ya chini.
Yeah.
Then what do you get? That pressure is equal to?
H times rho times G.
And that becomes the formula for pressure in liquids.
Thank you.
So the last question, I don't know who is this. The last question. Dogo, just a minute. Last question. And I hope kama ulikuwa na swali kama mwenzako walikuwa nayo, you have understood as I was explaining. So if your question has been answered, you don't have to keep listing your ad. But if you have a different question, let me just respond to it. Samuel Rukenya. Samuel.
Yes, Chana, I have a question.
Uh-huh.
From here, where we have said that rho times, this is volume times G.
Uh-huh.
I think I wanted to ask whether you can at least clarify some more, because I think I'm not quite understanding that well.
Pardon, where can I explain more?
Here, where we have said that we know that weight is equals to mass times gravity.
Uh-huh.
Here, where we have written that rho times volume times G is where that I'm not understanding. Right next to mass times gravity.
Now we have said that weight is equal to mass times gravity, sindio?
Yes.
Now, on my busa how hiyo ni tumeka hapo rho A, H and G. Uende hapo kwa note. Note that mass is equal to density times volume, sindio? Now, I want to understand where are we getting A, H, and G from? We have said that weight is equal to mg. Sawa sawa? Nikasema hapo note that mass is equal to density times volume. Sindio? Then nikauliza how do we get volume of because our diagram hapo ni cylinder, sindio? So how do we get volume of a cylinder?
Volume of a cylinder is equals to cross-section area times height.
Cross-section area yetu ni A, sindio? Na tuko na height as H, right? If you go back to what we have said, that M, mass is equal to density times volume, therefore mass is equal to density, which is rho, right?
Yes.
Times volume, which is, we have said now, tuweke volumetric kuwa ni A times H. Sindio? We have our mass as rho times A times H. Is it clear?
Yes.
Now we carry that statement back. Pale kwa umesema weight is equal to mg. Now replace m with what we have gotten hapo juu. Utapata weight is equal to tulikuwa tumesema, tumeenda na wewe vizuri mpaka ukapata mass, which is m, is equal to rho times A times H, si ndio? Now I want to go back to weight. Tulikuwa tumesema weight is equal to mg, right?
Yes, yes.
Can you replace that m na hiyo kitu, na hiyo nini sasa ya rho AH?
M.
Just let me just have this kidogo kwa board, so itakuwa
itakuwa AH, which is the volume, times rho times G.
Let me just do this working on the board so that we can move step by step. Tumesema just angalia kwa board. M is equal to rho times A times H. Tumepata hivyo? But we said that weight is equal to mass times gravity.
Mass times gravity, yes.
Ndio. So you replace hii mass ya chini hapa na hii mass tumepata hapa juu. So we have weight as M. M tumesema ni rho times area times H, then times G. Is it clear?
Oh, yes, it's now clear.
So we go back to what we had said, that pressure is equal to weight over area. Sawa?
Yes.
So we have our weight as rho times A times H times G, then all that divided by area. Sindio?
Area. Yes.
So this, we cancel out the two A's, zina cancel out. Then we are left with pressure is equal to rho
times
rho times H times G. Sindio?
Yes.
All right. I think now you can.
Thank you. Thank you.
Let's move on to something. Now let's move on to examples. Wale watu sasa, we move on to examples. Na kila mtu akona kalamu yake mahali, we do the examples of that concept. Let's have examples. The next thing is examples. And I want someone to let's move on. Examples. Just a minute. Examples. We have the first question. Someone to read for us that question. Question number 1. Mohammed, kidogo. Idris, not Idris, really, because Idris umeongea tena. Let's get from Onyango. Onyango? Onyango?
I'm getting you.
Get me now.
A diver working underwater is 15 meters below the surface of the sea. Calculate the pressure due to water experienced by the diver. Note, take gravity is equal to 10 newtons per kilogram and density of seawater to be equal to 1.03 grams per centimeter.
That is our first question. We have said, this is the Onyango. We've said the formula is H rho G. Sawa. Onyango, you can hear me? Now, we have said that the formula is H rho G. and our height is 15 meters, then our density should always be in kg per meters cube. Now, we are given our density as 1.03 grams per centimeters cubed. So what is the density in kg per meters cubed? What is that density? Itakuwa ni how many kg per meters cubed? How many?
1030.
1030. What do we do? Unafanya nini?
15 times 1030.
Yes.
The
What do we do?
That is the gravity that we have been given, which is 10.
So what do we do so that we can get the density in kg per meters cubed? Victor Katobu. Victor.
Yes.
What do we do to get the density in kg per meters cubed?
Pardon?
We are given our density in grams per centimeters cubed. Sindio?
Yes.
And we have said when we are working, our density must be in kg per meters cubed. So what do we do to that density to get it in kg per meters cubed?
You multiply by 1,000.
Multiply by 1,000. So can you get that pressure? What we're finding swali ya haraka. I know the working is there, but I want you to do your own way and get the same answer with them. I hope we are done with that question. That is why you look at the working, we have applied H rho G, and the dense and the height is 15 meters, density 1030, of course, kg per meters cubed, then times gravity, which is 10, and you get your pressure as 154,500 Newton per meters square. Note that. Everyone should be keen on that. That is the first question, the basic question of that concept. The next, example 2. Example 2. Let me get someone to read for us the question. This is who? Nixon Jeru. Nixon.
Yes, I'm here.
So me swali. Number 2.
The figure below shows a pail. If the liquid has a density of 0.79 grams per centimeter cubed, determine the pressure exerted at the bottom of the pail by the liquid.
By the liquid, and enlarge so that you can see that height.
45 centimeters.
Right.
Centimeters.
So what do we start by doing?
First, we turn the centimeters into meters. We get 0.45 meters. Then we head over to the density and change it to kg per meter cubed by multiplying it by 1,000. We get 790 kg per meter cubed. Then now we use the formula, pressure is equals to H rho G. H 0.45 meters times rho 790 kg per meter cubed times height 10 newtons per kg.
All right, and we get our answers what?
3,505 newtons per meter square.
Sasa nataka tufanye maswali sisi wenyewe. Let me give you a working example. Those are examples that I worked for you. Let's now work this one. Just a minute. Tufanye hizi maswali. Let's work number 1. Who is to read for us this question? Who is to read for us this question? Noel. Noel?
Yes. Calculate the pressure exerted by 76 millimeters column of mercury given that its density is 13.6 grams per centimeter cube.
Go on. Kila mtu afanye hiyo swali haraka haraka. Kila mtu afanye hiyo swali mbio mbio. Ukimaliza inua mkono so that you can see you. Nataka hiyo swali tufanywe na mtu wa kutoka 1P. So mtu wa 1P mwenye amaliza inua mkono. So akina Bryson, hebu hiyo mikono yenu iende chini. I want someone from 1P. Someone from 1P. Kevin Mwangi, you belong to 1P. Kevin Mwangi.
Yes.
You belong to 1P?
Yes.
Toa headphone, sauti iko chini. Uko na headphone?
No.
All right, go on now. Explain to us how you work that question.
First, we change the 76 millimeter into meters. We get 0.076 meters.
Sorry, you get what?
0.076
meters, right?
Then we change the density.
Change the density.
Get 15,600. 15,600 kilogram over meters cubed. Then the pressure will be 13,600.
Which is the formula we use?
Height times rho times gravity times.
So what do you get as the final answer?
10,336.
Just a minute.
Newton meter squared.
Right. Now, I still want to insist. I know from various classes mmeambiwa na walimu wenyu, and those who come from my classes nimewaambia pia, that when you are working any calculation in physics, formula will always give you the first mark. So I expect when you are working that problem, you start, first of all, unaandika formula hapo juu. Anytime you are working pressure in liquids, you start by writing that pressure is equal to H rho G. So I would expect if I was marking your paper, ningekuja nione, the first thing I would want to see is P is equal to H rho G. That is the first thing I would be looking in your paper. Because I know your teachers have insisted severally, and from various classes mmeambiwa na walimu wenyu, that any calculation in physics, we start by marking the formula and you get the first mark. And I must be sure mmeambiwa that unaweza anguka the working, but if you have the right formula, you must get the first mark. Sawa sawa. So una watu wanainua mikono. Let me get to what their concern is. Siwili John. Siwili John. John. Siwili.
Yes. Yes.
What is your concern? Sorry?
I didn't hear what the person was explaining.
You didn't hear what he was saying?
I'm saying that yes.
What is your concern?
I'm saying that I didn't hear explanation. The one who gave it, I didn't hear it well.
Ni network yako labda iko na shida, but let me just go back to what he is saying. Can you read the question? Read the question.
Calculate the pressure exerted by 76 millimeter column of mercury given that its density is 13.6 grams per cube centimeters.
Now we have said the formula is H rho G. Sawa sawa.
Yes.
Then our H tumepewa, which is 76 millimeters, right?
Yeah. Yes.
So we must convert our 76 millimeters into meters because our SI unit is supposed to be meters. So,
yes.
Then convert that one into meters. Unapata ngapi?
0.076 meters.
That is the height. That is H. So.
Yes.
Tumepewa density yetu ni 13.6 grams per centimeters cubed. Convert that one into kg per meters cubed. What do you do?
Pardon?
Convert that density, which is 13.6 grams per centimeters cubed, into kg per meters cubed.
Now that's the formula I don't know.
When you come from which class?
1 Northwest.
1 Northwest. I must be sure when we are doing about measurement, muliambiwa that what is the SI unit of density?
Yes.
What was muliambiwa na mwalimu wenu when we were doing about measurement 1? Mlikuwa mmesoma density, si ndio?
Yes.
Mkaambiwa what is the SI unit of density?
I can't hear you well.
Network yako labda iko na shinda. What is the SI unit of density?
The SI unit of
density. So really?
Yes.
What is the SI unit of density?
Grams per cubic centimeters.
No. It is kg per meters cubed. Also,
yes.
In converting grams per centimeters cubed to kg per meters cubed, what do we do?
We multiply by 1000 kg meters cubed.
Then that is what we're supposed to do. 13.6 times 1000. What do you get?
You get 13,600.
Exactly. Then apply the formula. H rho G. G is 10.
Yes.
G is supposed to be 10, sindio?
Yes.
So then you multiply. That is, we got our height to be 0.076. Then density uko nayo, na G uko nayo. Just get the answer. Sawa?
Yes.
All right.
Yes.
Let's get someone now to read for us question 2. Second question. Who is this? Mtu asomea swali. Bryson Nyaga. Bryson.
Yes.
Usomea swali ya pili.
Okay, a column of glycerin 8.20 meters high, a column of seawater 10.08 meters high, a column of mercury 0.76 meters high, and a column of fresh water 10.34 meters high exert the same pressure at the bottom of a container. Arrange these substances in decreasing order of their densities.
All right. What do we do in that question? You were told a column of glycerin, which is 8.20 meters high. Then a column of seawater, 10.08 meters high. Column of mercury, 0.76 meters high. And column of fresh water, 10.34 meters high. Exert the same pressure at the bottom of the container. Arrange these substances in decreasing order of their densities. That is, anza na ile kubwa ukienda kwa ile ndogo. Can we arrange those substances in their decreasing order of densities? What we are testing in that case, we are testing that pressure changes with density because the height they are varying. But despite the height varying, they still have the same height, they still have the same pressure at the bottom. Because one has got a bigger column than the other one, but they still exert the same pressure. So how do we arrange them? Kila mtu take time kwanza zipange. I'll give you 1 minute each. Kila mtu dakika 2 hivi. Zipange kwanza, then we can respond on them. 1 minute, kila mtu akuwa anazipanga, then you tell me what to do. Dakika mbili ila mtu akuwa amemalizana hiyo swali. I hope now we are done. I hope we are done so that we can explain to those who might be having a problem in it. Let me get someone to respond on that. This is Adrian Mukira. Adrian, give me the arrangement.
The first in decreasing densities. So the one that has the highest density will be mercury, then glycerin, then seawater, and lastly fresh water.
Fresh water. Anyone with a different answer? Or would you want more explanation? Anyone with a different answer? Naona mikono zimenuliwa bado. Lennox Malanda. Lennox.
Sure.
Yes. You have a different view?
I need the explanation. I haven't understood the question well.
That is Lennox. Let me get from someone else before I explain to Lennox. Someone else with a different concern. Someone. This is Nixon Jeru. Nixon.
Excuse me, sir. Is there a working to the question, or are we basing it on the knowledge of the densities of the liquids?
We are basing that on the knowledge of density and the heights. So.
Yes.
We are not doing any calculation on that.
Okay.
All right. Any other concern before I respond to Lennox? James Okello. Okello James. Okello.
Mute. Yes, sir.
Yes. You are concerned?
No, I have an.
You answered.
Yes, I think that's from the one with the lowest height. That is mercury, glycerin, then seawater, then finally fresh water.
That is the. Okay. Now let me just do an explanation to someone like Okello who had issues. Not Okello, but Lennox. There was Lennox alikuwa na issue anasema aelewi swali. Lennox, where are you? Lennox, can you raise up your hand so that I can unmute you again? Is it Lennox? Lennox. All right. Now I want us to move together with you. Read the question. Come your swali.
A column of glycerin 8.2 meters high. A column of seawater.
Kwanza, Lennox. Uko na kalamu?
Yes.
Ukisoma glycerin iandike hapo. Glycerin iko na
8.20 meters high.
Then move on to the next one. Seawater.
A column of seawater 10.08 meters high. A column of mercury 0.
All right.
A column of mercury of 0.76 meters high. A column of fresh water 10.34 meters high. Exert the same pressure at the bottom of the container. Arrange these substances in decreasing order of their densities.
Let me just have a sketch on the board. Let me assume this is a glycerin. This is this tuanza glycerin to kind of seawater. Then we went on to mercury. Then the last one is fresh water. Sindio?
Yes.
Then we are told that they have got different heights. A column is the same as height. E iko na 8.2. Then the other one has got 10. Iko juu yake kidogo. That is 10. Then the other one has got 0.7. Iko chini kabisa. Then the other one has got 10. Iko 10.34. Now, if you look at those, the heights are changing, but the pressure is the same. That means what is affecting the pressure in this case is the density. Sindio?
Yes.
Now, if you look at that, kuna ile iko na height kidogo sana, but it is exacting the same pressure with the one with the biggest height. Sindio?
Yes.
That means that ile iko na height kidogo, but in the exact same pressure, that means biko na density kubwa. Sindio?
Yeah.
Therefore, we arrange them in the ascending order of their heights, because ile kama uko na height kadogo una exact pressure the same na mimi, then that means wao uko na nguvu mingi kuliko mimi in terms of density, si ndio?
Yes.
Therefore, you arrange them in terms of their ascending columns. So which one has the smallest height?
Smallest height is mercury.
So that mercury becomes the first one, followed by
glycerin.
Followed by
then seawater. And fresh water lastly.
Fresh water is on a very big column, lakini in exact the same pressure na mercury. That means iko na density kidogo sana. Also.
Yes.
All right, that is what we're supposed to have done. So we're supposed to have mercury, glycerin, seawater, and fresh water. That is the working. That is the answer expected from every one of you. Swali, wenye meno mikono ni swali ama kuna swali, kindly let me know before we move on to the next thing. Swali, watu wamenunua mkono. Swali. Let me get the question from Kimathi. Kimathi? 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 I don't know what is not happening. Kimathi uongee, nimekuwa mute. Ama una swali? Let's get the question from Ezra Monaya. Ezra. Ezra. What's not happening then? Watu wameinua mkono na waongee. Someone, this is Hadan. I mean Mohammed Hadan.
Yeah, can you hear me?
Yes, Hadan.
Said earlier.
Butu headphones kama uko nazo.
Okay, you said earlier that the formula that does not require.
The formula does not require. Sorry?
When you're explaining the fluid formula, you say that it does not depend on cross-sectional area. Why? I don't get that point. Because we are using pressure to get force over area, which is cross-section.
Why did we use what we did on that question, on that deriving of the formula? Tulitumia, we used a container which has got a known cross-sectional area, which is as a definite shape. So that means our liquid ikuwa kwa hiyo container, it has a definite shape, si ndio?
Yes.
But we get to a point penye we have a container without definite shape, Therefore, our liquid does not have definite shape, right? Am I clear?
Yes, you're clear.
So therefore, if you don't have a definite area, you cannot use area in finding the density, the pressure of a liquid. That is why I said that we don't use area in getting the pressure of liquids, because it's very hard for us to get the area of a liquid, especially if the liquid is put in a container without a definite shape. Also, but when we were driving that formula, tulitumia a container with a definite shape. That is why we were able to get a definite area. Na ikatusaidia kupata the formula, so that we arrived to a formula that now eliminates area inatoka, and we are left with a formula which is constant in finding the pressure of liquids. So,
Yes, and if it's a closed container, the pressure will be the same.
sorry?
And if it is a closed container, it will be the same.
Can you be loud enough kidogo? Sauti yako iko chini. I don't know kama umevaa headphones ama ni nini ba?
If it is a closed container,
Uh-huh.
the pressure be the same.
If it's a closed container,
Yes.
of course it will be the same. Regardless, even if it is a closed container, the pressure will be the same. But we are getting to the concept of the atmospheric pressure that will introduce something new. If it's a closed container, utakuta haina atmospheric pressure, but we are yet to get to atmospheric pressure. And that is our next step I want us to discuss before time comes to an end. Also, all right, let's move on to the next thing. I don't know how much time. Let's get the last question. Who else has a different question? Idris Juma. Idris.
Yes, teacher.
You have
Yes, I have a question.
Go on.
I wanted to ask, why must we change the measurement of the height to meters?
Because we said we want to get pressure. What is, first of all, we are concerned with getting pressure. Sindio?
Yes.
What is the unit of pressure?
Pressure is equal to?
No, SI unit of pressure. Yes? Idris?
Yes, yeah.
SI unit of pressure ni?
Newtons per meters cubic.
Newton per meter squared, not cubic. Newtons per meters squared.
Yes.
Also, so in our working, we must work with all the variables zikuwa na meters, not any other factor, because we must get our pressure in Newton per meters. So,
okay, yeah.
Because ukitumia centimeters and we expect that our answer in pressure must be in meters, then you'll be working with different units. So,
yes.
So that is why we are converting our height into meters and our density into kg per meters. So that when we come to the last answer of pressure, we'll be having our answer in meters.
Thank you.
Who else? The last question, probably. The last question before. I don't know. What time we are lost to.
Excuse me, sir.
Who is this?
Nixon Jero.
All right.
In exam, this question of arranging in descending order, will they ask it differently, or why? Will they ask why, or the question will just be termed?
It can be twisted in different ways, or it can be the same the way it is. What I wanted you to get to that question, Jero,
yes,
is get to understand the factor that we mentioned hapo juu tukasema pressure in liquid is affected by density. So it's upon you, depending on how they will twist the question. Of course, they must give in such a way that utaona kuna moja ile iko na column kidogo, or the height is small, then that one has got the highest density. So
yes.
So it can be twisted in any way, but at the end of the day, they will give you variables the column which is changing. Ukiangalia ile iko na column kidogo na iko na pressure iko juu, that means hiyo ndio iko na density mingi. Just that. They might twist their English, but at the end of the day, it will be the same thing. So,
Yes, can they ask why this is caused, or do we just write because density and height relate?
If they ask why have you given your answers in that one?
Yes, why this is happening?
Then you can, if they ask you why you gave your arrangement in that manner, then you can just say because density, then pressure in liquid increases with density. Sindio?
Yes.
Pressure in liquid increases with density. Therefore, the liquid with the small column has got the highest density.
Yes.
That's all.
Yes.
Right. There is one more thing I wanted us to discuss before time get us. Kelvin Kariuki, your last question. Kelvin Kariuki, the last question from Kelvin. Kariuki,
Yes.
Kelvin. Yes.
Yes, sir. Can we also calculate? Calculate by taking the density, the pressure over the density times gravitational acceleration.
Pardon?
In which you will arrange the densities.
We'll arrange the densities.
Yes, you can you also do that?
Am I getting your question?
I'm saying you take the height.
And to height already.
Then you multiply by the gravitational acceleration.
Then what do you get?
Then you divide. Then you divide by the pressure, because you know the density of water, fresh water. You divide all of them and then you arrange them.
Now the problem is that we do not know the density of glycerin and to do hovered. We do not know the density
I'm
of
saying
seawater.
Because you know you have the fresh water, the height is 10.34 meters. You multiply by 10, which is the gravitational acceleration. Then you divide by 1. You divide by the density of water, which you know is 10.34 times 1,000. All of them, because they have the same density. I've done that, and then I found the density of mercury to be 13,600. Then the other densities of glycerin and also the density for seawater.
From mercury and the glycerin and seawater.
Glycerin and also seawater. Can you also do that?
Now the problem, if we were given the pressure, we would be able to get the density. But since hatuna pressure hapo hatujapewa, si ndio?
Yes.
Because if they had given us specific pressure that they are exacting, then we would be able to do that. But in this case, hatujapewa pressure na hatujui density of the rest. That is what you're supposed to be getting, si ndio?
Yes.
If we were given the pressure that the 4 of them are exacting, then we would go by that formula. And now that we are not given the pressure, we cannot go by that. Yes, sir?
Yes.
All right.
Okay, thank you.
So the last thing I would want to mention, we have around 2 minutes to go, but I can't go without mentioning. Now, let me just go on, and the last thing I would want us to get, so that at least it can give you the assignment. Just a minute, within 1 minute I will be through before the time comes to an end. There is this last bit, the bit of the atmospheric pressure. But I don't know whether I would want to refer you guys, go on usome the topic of the concept of atmospheric pressure. That is why we pick on from next week. Because nikisema to explain sahi, we might be caught up by time. So what you do, all of you, read on the atmospheric pressure and then get to know how we explain the crashing can experiment. Because what we have here, those who have read before, that is called the crashing can experiment. next week when we'll be having our lesson, I would want to know someone to explain to us what happens in a crashing can and it happens because of what. So next week, Musome about crashing can. Within the course of the week, sorry, Musome crashing can, and then you read on the atmospheric pressure and the crashing can, then try to do some examples. So that next week we'll explain about that, the crashing can, tufanye exam moja, then we will be talking about the Pascal's principle. So everyone, ensure you are there in the Pascal's principle by next week, and also about the crashing can experiment. So I hope the lesson was okay. I want to respond, no, watu wanne wameinua mikono. So unless I hear what they're saying, then we call it a day. So I'll start with this is huyu mtu ako na jina inakaa weird na umeinua mkono 23127. Hiyo jina yako next time we change. We don't want to start names again. Yes, 23127.
Yes.
Who is this?
I was asking. You're recording this meeting. I was asking if you could send it to us.
All right. That one can be last with the class, Mr. Moji. What's up?
Yeah. Yes, sir.
Class, takutumia.
Yeah.
Idris, your question?
Teacher.
Idris?
Yes, excuse me, teacher. As we have skipped that topic of force. The concept of teacher, we did not cover it with the teacher.
You come from one of these?
Yes.
Who is your teacher?
Mr. Ndambuki.
I was told that you were supposed to have come and everyone was supposed to have come and first. And Mr. Ndambuki aliwaambia msomi. That is what Mr. Ndambuki said. What you do?
Yes.
What you do, just go back to the topic of force during your free time, read, and then if you don't get to understand anything, then talk to me.
Okay, teacher. Especially the concept of mass and weight.
Yes. Because kama ukumbuki hiyo mzuri kwa pressure will have a problem. So go back there, read about mass and weight, how they relate, and then if there isn't a problem, then get my number, then talk to me. That's all.
Okay, teacher.
All right. Any other question? Any other question? Nataka sasa, Manuel.
Yes.
You are concerned?
Yes, sure. What's the density of seawater?
Density of seawater is not really hatuwezi sema hiyo iko established. It depends with the amount of sea in that. As in hatuwezi kusema tuko na specific density ya seawater. Because different seas have got different amount of salinity. So hiyo density ikuangi established, ikuangi constant kama vile tunajua fresh water. Sawa?
Okay, thank you.
Because different seas have got different amount of salinity, so hawezi ukasema ni specific due to different salinity of sea of different seas. We know fresh water ndo tunajua ni 1 gram per centimeters cubed. Sawa?
Yes.
So we can stop there. Tunataka mtu atuombee tumaliza class. Who is to pray for us? Who is to pray? Ben was the first one to raise up his hand. Ben. Shortly.
Yeah, let's pray.
All right.
Our Heavenly Father, we thank you for the gift of life that you have given unto us. We thank you for you have protected us. We thank you for you have been with us since the starting of the lesson and now it's ending. You have been with us. The lesson was good. You have learned something new, Father. And for the rest of the lessons, may you also take control and help them helpful unto us. It is in Jesus' name we pray. Amen.
All right. Nice time, all of you. Najua sasa mnaongojea kusema nice time nyinyi wote. I will unmute all of you. Watu waseme nice time tukienda.